All right. The next part of the summer homework is inequalities. Mostly quadratic inequalities is what we'll use this year, but we'll do some other ones as well. I would expect that most of you do not remember this particularly well from Algebra 2 because we only spent a day on it, and then my guess is you didn't use it very much in pre-calculus, but it's going to be very important in calculus. So here are the types of questions we want to answer. When is this function positive? Another way of thinking about that is when is this greater than 0? That's what positive means. It's above 0. That's where the positive numbers are. And so we have a technique here, and our technique is to factor this function and see when is that factor. We're going to factor it completely. We want to see when that factored function is greater than or equal to 0. The reason this helps is because the factored form, we can tell very easily where it is equal to 0. F of x equals 0 at x equals 0, because 2 times 0 is 0, -3, and -2. Those are the three values that f of x is equal to 0. And what I'm going to do is I'm going to make something called a sign chart. And this is going to help us see where the function is positive. What we're going to do is we're going to leave a space, and then we're going to put our lowest x value, -3. Then we're going to leave a space, and we're going to put our next lowest x value. We're going to leave a space, put our highest x value, and then we're going to leave a space at the end. So at x equals -3, the y value is 0. At x is -2, the y value is 0. And at x equals 0, the y value is 0. We know that because it's factored, and any factor that makes any value that makes any of the factors zeros makes the function 0. So these are the only three places that this function crosses 0. It can help to think about it graphically. We've got a cubic that crosses at -3, -2, and 0. And on a graph, we can kind of see what's going on. It's going to be positive here and here. We're going to see how to do this using a sign chart, but this is what we should be seeing. Because these are the only places it crosses 0, it can't just jump from negative to positive without crossing 0. And so all we have to do is check a single value less than -3, and that'll tell us that all of the values less than -3 are either positive or negative. So I'm going to pick -4. When x is -4, what happens is 2 times -4 is a negative, times -4 plus 3 is -1, which is a negative. I don't actually care what number it is. -4 plus 2 is -2, which is a negative. So if I pick a number less than 3, less than -3, you should see that it doesn't matter if I pick -4 or any negative number. All of these will be negative, and a negative times a negative is a positive. Positive times a negative is a negative. All numbers less than -3 for x will make the y value less than 0. Then I can pick a number between -3 and 2, like -2.5. So -2.5, when I plug it in, 2 times negative is a negative. -2.5 plus 3 will be a positive. -2.5 plus 2 will be a negative. Here the positive was bigger, here the negative was bigger. And you should be able to see that any number between -3 and 2 will make this one positive, but this one negative. And so now we've got a negative times a positive, which is a negative, and then a negative times a negative is a positive. You can basically count up and see, is it an even number of negatives or an odd number of negatives? A negative times a negative is a positive, and so that makes it positive. All right, we pick a number between -2 and 0. So -1 seems like a good choice. 2 times -1 is a negative. -1 plus 3 is a positive. -1 plus 2 is a positive. And now we've got a positive times a positive is a positive, times a negative is a negative. There's an odd number of negatives, so it's a negative. So all the numbers between -2 and 0 will make the y value negative. And if we pick a number greater than 0, any positive number, like 7, 2 times 7 will be a positive number, 7 plus 3 will be a positive number, 7 plus 2 will be a positive number. All the numbers are positive. And so we end up finding what we were looking for, which is where is this function greater than 0? Well, it's greater than 0 here and greater than 0 here. And we usually write our answer in interval notation. We say f of x is positive on the interval from -3 to -2. We actually used a closed interval here. I don't really want to go into it right now. Union from 0 to infinity. So here's this interval from -3 to -2, and from 0 to infinity. We never get to infinity, so that's an open interval there. Okay. The next type of question, we can answer this using a similar method. When does this function change sign? And again, I'm going to factor it. And I get x squared minus 7. And I want to know where this is equal to 0 first. I'm just going to solve to see when does this equal 0, because that's where it could change sign. This can factor even more. We can treat this as a difference of two squares and factor x squared minus 7. Even though there is no whole number that multiplies times itself to make 7, we can do x minus square root of 7 times x plus the square root of 7 equals 0. So this function, g of x equals 0, at x equals 0, square root of 7, and negative square root of 7. Again, just because it's equal to 0 doesn't mean it changed signs there. So I'm going to make a sign chart and see what's going on here. So at negative square root of 7, that's my lowest 0. And negative square root of 7, the function's equal to 0. Then the middle one is 0. And the greatest one is square root of 7. It's important we go in order, otherwise this will not work correctly. We pick a number that is less than negative square root of 7, like negative 100. And when we plug it in, a negative number squared is a positive number. A negative number minus a number is going to be negative. And negative 100 plus square root of 7 is going to be a negative. So a positive times a negative is a positive. Okay. Between negative 7 and square root of 7 and 0. So there's like a number that is closer to 0 than negative square root of 7, like negative 1. A negative number squared is a positive. Negative 1 minus square root of 7 is a negative. But negative 1 plus square root of 7, the square root of 7 was bigger than negative 1, and so we end up with a positive times a positive, which is a negative. You might start to think, hey, doesn't this change? It just goes negative, positive, negative, positive. Well, it does look like that, but that is not correct. Let's pick a number bigger than 0, but smaller than square root of 7, like 1. When we plug in 1 squared is a positive number. 1 minus the square root of 7 is a negative number. And 1 plus the square root of 7 is a positive number. So this also multiplies out to be a negative. When we put a number bigger than square root of 7, like 50 in there, we'll get a positive times a positive times a positive. And now we end up with a positive number. So when does g of x change signs? Let's make sure we actually answer the question that was asked. G of x changes sign at x equals negative square root of 7 and x equals square root of 7, but not at 0. It didn't actually change sign from negative to positive. It remained negative. Let's look at a graph and see what's going on here, because I think it is elucidating. If we draw a graph, we've got a 0 at x equals 0, a 0 at x equals negative square root of 7, and a 0 at x equals square root of 7. This is a quartic with a positive coefficient, so we know because it's an even polynomial, both ends point up. And if you remember from Algebra 2, this is a double root. It has a multiplicity of 2. So when we draw the graph, it kind of bounces off. It makes a little mini parabola there before going back up. And this is kind of what we saw. It changed signs at negative square root of 7. It changed signs here, but here it didn't actually change signs. It remained negative. So that's something we need to check. All right, I'm going to do one, maybe, I don't know, maybe I'll do all these. Who knows? This next one, we have things dividing now. Again, we want to see where this is negative. So I'm going to rewrite this by factoring the denominator. X plus 5 times x minus 4. And I want to know where this is less than 0. Notice that this could cancel out. I could say that this is also equal to 1 over x minus 4 as long as x doesn't equal negative 5, because there's a hole there. So I want to see where this is less than 0. Again, I can make a sign chart. And there are two ways to think about it. I could use the unsimplified or the simplified one. Either way, I need to pay attention to that -5 because there's an issue there. When x is -5, the function is undefined. There is no value. When x is 4, the function is undefined. And if we pick a number less than -5, if we do it here, we will get so like -6 or something.